Good morning, everyone. Thank you for coming today. On behalf of Poladrone, I would like to welcome you, to extend a very warm welcome to all of you. We appreciate you taking time off your busy schedules to join us today. We hope you will find the program we have lined up for you to be fruitful and engaging. Before we begin to curb the spread of COVID-19, all attendees are required to wear masks at all times and keep a safe social distance from one another. If you need hand sanitizer, we have them placed at the registration booth and at the table at the back of the auditorium. We will be having a live product demonstration at the entrance of this building later. Please pay special attention to the tape markings on the floor and always keep 1 meter space between yourself and others. Your cooperation is much appreciated. For attendees who require water, we are providing mineral water and it is located at the back of this auditorium. For attendees who needs to use the restroom, it is located downstairs next to the lift. Let me first introduce you the agenda. We will set the ball rolling with an introduction on DJI Zenmuse P1 and Matrice 300 RTK, the most powerful tool which has revolutionized area surveying. This will be a 40-minute presentation. At 10:15 a.m., we will have a Q&A session. You may raise your hand for questions. Our staff will hand you the microphone to you. At 10:50 a.m., we will have a 25-minute product demonstration at the front of the building. We will end our seminar at 11:10 a.m. I am sure it is going to be a great 2 hours of interaction and learning for all of us. I will now invite Incheck Shazwan from Poladrone sales team on stage to highlight the key features of DJI Zenmuse P1 and Matrice 300 RTK.
That's my 1, 2, 3. Alright, everyone can hear my voice? Okay, clear? Right, thank you, Eva. Hope everyone here have followed the SOP and follow the rules and regulations. So together we prevent the spreading of COVID-19 together in Malaysia. Alright, so today I'm a sales representative. I will present about the product itself for today's events, which is the DJI Matrice 300 RTK, which is here, and also the payload itself, the Zenyus P1. Alright, before I proceed with the actual product presentation itself, I would like to have a short brief about our Poladrone company. So, we are Poladrone founded in 2016, where we are focusing on the agri-tech industry, and across Malaysia, Thailand, and also Indonesia. We also provide enterprise drones, where drones is actually an object that fly with compatible attached sensor and payloads. We can collect very valuable data, and then after that, with analytics software, we can further process it. Valuable data that we collected for based on your business requirement. Right, next is we are the tier 1 distributor for the DJI Enterprise here in Malaysia, and also many leading industry-leading payloads, such as the Megasense, Centera, and also Flirt. Then the next one is we have covered more than 500,000 of hectare for the data analysis for our corporate clients, and also we have provided more than 1,000 units of enterprise drones for their operations, such as inspections, surveys, and surveillance. Not only that, we also have more than 500 participants that we train under our Drone Academy, which is Drone Academy Asia, that are located here in Cyberjaya. Right? So here is the services that we offer in Poladrones. So there are 4. First one is the turnkey project, where from A to Z, we will be pre-plan and do the business solution for you guys. Then the second one is we provide under the partnership of Drone Academy Asia. They provide various courses for professional drone operator that you can join and train with. Then the third one is the product procurement, where basically we can procure any hardware, equipment, and also software that related to the drone industry based on your business requirement. Also, the last one is the interesting part is that we also have a dedicated R&D specialist that are focusing on the betterment of using drones in various industries. Yep. So talking about the using drones in various industries, the drone technology has been adopted in the widespread of technology in various industries. So it has dramatically increased the efficiency, the productivity of the data collected compared to the traditional method one. So here you can see in front of the slides, there are some of the several that the drone can contribute on, which is the first one is the topographic mapping, and the second one is cadastral surveying, disaster site monitoring, and also aerial surveying. So talking about the aerial surveying, let me introduce the top of the line, the flagship product from the DJI brand itself, which is the Matrice 300 RTK. Yep. So here is the most top of the line of the DJI brand. So it set a new standards for the industrial UAV solution in the market. Right. What's so special about this DJI Matrice 300 RTK? There's a lot of pack of features inside it. So can we call it? You can call it M300, just a very short name, sweet name. So this one is a very long, so you can just call it M300 for now. Okay. For the superior performance, M300's maximum can have a maximum takeoff weight of 9 kg and also can support around 2.7 kg of payloads. What's unique about this M300 is that it can configure on multiple type of payloads. So you can configure a singular, a dual, and also a triple payload configurations. So you can see here in front some of the lines for the payload that DJI offer, which is the H20 series, P1s, and the L1 is there for LiDAR, Z30 more focusing on the zoom sites, STS and SC2. That one is for thermal data collections. Alright, not only that, the DJI M300 also can be configured on the third-party payloads, which is you can see you can spec it with the spotlight, for example, and with megaphone. That one you can use for border inspections. That one more focusing on the immigration departments. And also you can use spec it with the gas detector, for example, with the thermal imaging sensor. You can use for detecting any gas leaking for the oil and gas sites. So here I'm showing that the M300 can have a very superior versatility and flexibility to configure in many kind of payloads that offer in the market. Right? So other than the multiple payload configuration, it is also enhanced the flight time, which is the optimal flight time of the Matrice 300 is 55 minutes. You can see in the table below here, the comparison between the previous M300 series, the M210, with the attached payloads, Z30, it only came up with the 15 minutes only. So for the current previous one, the current one, the M300 with the attached payload, we can have the flight time until 36 minutes. So there is a very big improvement in terms of the flight time, which is 140%. Alright, here is the very interesting features inside the M300 where never say never, things might happen, bad thing might happen. So let's say just in case a bird attack your drones in the middle of your operations or one of your propeller is not well functioning. So M300 has these features of called 3 propeller emergency landing where you can see the M300 is spin quite vigorously very well, but actually it is descending in a very controlled manner. So most important part is that all the body of the M300 is still in contact in one pieces. So at most the worst case is that only the propeller has been broken, so you just can swap it with the new one and continue with the operation on the day. Right? So after that is some of the superior performance and features that I have in the M300. So let's take a look on the payload itself, which is the Zenyus P1. So for the Zenyus P1, the unique is for this one is it compared with a full frame size sensor. To compare it with the Phantom 4, this one is only used a 1-inch sensor, which is 3 times much more smaller than this one. So it paired with a lot of features by using the full frame. I will explain it a bit later. So you also have the interchangeable fixed focal lenses. You can change the lenses there based on your needs. You can change to 24 and 50mm. And it also have a 3-axis gimbal, where every picture that you took will be stabilized and will not have any like shaky or any blurring. And the output of the picture also will be very high quality and increase the efficiency and the accuracy of your picture that you took. Right. These are the key features that offered by the P1s. First one is the accuracy of the picture that we took without using the CCP. Also can be achievable by up to 3 cm to 5 cm of accuracy wise. And also very high efficiency, where it can cover up to 3 km per square in the single flight. And also with the full frame sensor, it comes with very high resolution, which is 45 megapixels. And also have the smart optic features, where I will explain a little bit after this. This one is more towards the 3D modeling. And then the other two is, I think, the necessary features for surveying methods, where we need a global mechanical shutter, so we can avoid any motion blur or any distortion in your map. So you no need to do the map again. And also you have a time sync 2.0. What is that time sync 2.0 does is that it will synchronize the coordinate of the camera itself with the flight controller and also the antenna. So they can do the corrections in a real time to have and achieve the high accuracy as possible. Right, so to cover it all again, the P1 compared with 45 megapixels and also have the time sync 2.0 and very high sensitivity. Alright, so I think you have a big clear view on the features that have been offered in the M300 and also the P1s. So let's take a look on the actual working flow on the surveying solutions. So here is the 3 basic stages on doing the surveying methods. So the first stage is using by doing the missing design. It is more like pre-planning to plan out where of the area of interest you want to map out. And then after that, you have create your plans. You can deploy to the second stage, where we deploy all the information to the drones to execute all the mission. So you will collect all the data. And then on the third stage, you will stitch all the data that have been collected on the second stage to have an output based on your requirement. Right? So here is an example of using the P1 for the 2D auto mosaic. So after this, using the analytic, you can have an overview of your area of interest and can do the measurement. So you can see, you can have the measurement, exact measurement for your boundary parameter, and also you can also measure the road length and etc. Right, this is what I mentioned before for the P1 features, which is a smart object capture for 3D modeling. So basically, the drones, the P1 will capture automatically. The gimbal will automatically rotate based on what kind of picture that they need. So to compare with the Phantom 4, to generate the 3D model, you need to have at least 5 mission flights to create the 3D model. But by using this smart object capture, you only need 1 mission flight. So So the gimbal will do all the necessary capture to taking the picture. So it will save the time for post-processing because you only have the necessary pictures. Yeah. So that is some of the features that are offered by the P1s, and later after the case study we'll explain a little bit more about on how the actual output of it. So now I'm showing the inspection wise for the M300. These are the three features that we offer in M300 for inspections that will help you to operate your missions more easy. So the first one is the Waypoint 2.0, and the second one is the live mission recording and AI spot check. So for the Waypoint 2.0, you can set up a waypoint up to 65,535 waypoints. So you can see in the picture, you can set 1, 2, 3, 4, 5, 6, and so on. So the drone will follow all the points that you have set up and do the action that you want to do. So you can do like until 65,000 points. Yeah. And then this one is a live mission recording. So for example, you want to inspect the power lines. Here, you can first you can just manually operate it. And for example, you want to take picture there and then take picture there. So the drone itself will record all the routes and all the action that you have done. So it will save in the drones. So for the next time you want to come back and do the same inspection, you just resume all the mission that have been saved. So you will remember on what kind of action you have made before. So you can do the comparison on the first flight, the second flight to see any difference. For example, maybe like they have like corrosion or misalignment. So you can do a report for that. Right here is the AI spot check. So you can select the area that you want to take a picture. So the AI will learn and take exact same border picture of it. So every time you do the flight missions. So yeah, this is some of the superior spec and features that have been packed inside the M300 and also the P1. So here, yep, take a look in the video about the P1. I hope everyone enjoyed the video. So that's it for today's product presentation. Thank you very much.
The world of work was once again revolutionized when DJI launched the new enterprise flagship platform, the Matrice 300 RTK. With the new Zenyus P1, unlock more of its potential. The P1 integrates a full-frame camera with interchangeable fixed-focus lenses on a 3-axis stabilized gimbal. It is an efficient, accurate payload designed for photogrammetry. For the first time, DJI uses a full-frame sensor with more microns in each pixel to give you higher image quality. At 45 megapixels and with short shooting intervals, the camera can capture high-resolution images of large areas in short flights. In just 4 flights, 140 minutes. Collect data for 10 kilometers squared of 2D orthomosaics. What's more, the P1 syncs time across the camera, gimbal, flight controller, and RTK module to deliver centimeter-level accurate data. Its global mechanical shutter with a shutter speed of 1/2000 seconds prevents the jello effect, keeping images crisp even during high-speed flights while meeting accuracy requirements of 1:500 scale cadastral surveys. Thanks to the flexible 3-axis gimbal, Smart Oblique Capture simplifies oblique photography for you to quickly generate highly accurate 3D models. In areas with elevation changes, flight paths that follow the terrain let you fly safely while improving the accuracy of data outputs. Traditional geological surveys require teams to hang from dangerous slopes. Now, with the M300 RTK and P1, map-of-the-object photogrammetry missions are easier than ever. Vertical slopes and mountain ranges can be modeled with a millimeter-level resolution, so teams can investigate, measure, and evaluate these hazard sites. Use this combo for AEC and surveying applications to quickly acquire 2D and 3D data for all phases of the project lifecycle, including design, acceptance, inspection, and maintenance. In emergency response, immediate access to the latest intel is crucial. When used with DJI Terra, the solution enables real-time mapping, so teams can have eyes on a large area to quickly make informed decisions. The Zenyus P1 and M300 RTK solution is unprecedentedly efficient, accurate, intelligent, and safe, setting a new benchmark as your new go-to tool for aerial survey.
Thank you, Injesh Hassan, for the wonderful presentation earlier. We are privileged to have Mr. JC, the CEO of Poladrone, to go through the key findings of case study. Welcome, Mr. JC.
Testing. Good morning, everyone. It's great to see everyone here today after one entire year or more of lockdown. I think it's the first time that we're doing a physical event after the lockdown last year, and really it's been quite a journey for us as well as a company. How do we do engineering work remotely, which has never been done before in the history of mankind? So it has been a challenging time for us, but it's good to see everyone back here today, and we hope that a physical presentation would make a lot and bring a lot more value to everyone. So as a bit of an engineering company and as an engineer myself, I'm always amazed by what DJI puts out. The features, everything looks amazing, but there's always one question that we have. It's how does it work in real life? Does it really hit that flight time, the accuracy, the claims that they make? And that's why, as an engineering company, we always pride ourselves to really test, push the products before we bring it to the market in Malaysia. And that's where we like to thank DJI as well, where before they send the production units to us, they would always give us demo units, which we are able to test in Malaysia in real life condition. For example, for survey T1, connect to Japan network to see what's the kind of crew accuracy and performance of it. And that's what I'll be sharing today, the kind of test results that we have. So I understand that there has been a lot of people that may not be from the survey industry here. So the case study that I'll go into may be slightly technical, so I apologize in advance for that. But for the surveyors, it may be too simple, so feel free to ask more questions if you want. Alright, so that's just the outline of it. I'll run through the background of our survey area and our test itself. Then I'll run through a bit of an accuracy verification, where we verify the accuracy of the auto mosaic with control points. And we didn't have a benchmark point here, but we did set up a static observation to record the points. The resolution comparison of the Matrice 300 P1 versus the very popular survey mapping drone, the Fender 4 Rdk or Fender 4 Pro, that most of the surveyors use right now. Of course, a head-to-head on comparison with these two platforms as well, which is from the past records and data that we have the most popular drone, the Fender 4 Pro, Fender 4 Rdk. And of course, to wrap up the conclusion and any Q&A after. So before I jump into the case study itself, just want to clear up one very basic thing in the field of survey and area mapping. It's what is the definition between accuracy, precision, and of course the last one, resolution, which isn't really available or taken into consider factor for crediting the survey work. So as you can see on the left side, that's what we call low precision and low accuracy, where the targets are spread out and it's not off center. Then we have high precision, where the targets are all together, but it's off center again. Of course, we have high precision and high accuracy, which means the targets and the data collected is all correct, the equipment is working fine, plus it's tied back to a known point. Typically in the survey world, we use the benchmark point. It's all tied back to that. And for drones, of course, you have one more factor to consider. Depending on how far we fly, what are the sensors we are using, the resolution of it. Where end of the day, for area surveying, if you don't have resolution, naturally you would not have precision and accuracy, because you just can't see the data, regardless of how accurate your data are. So the equipment that we use for this case study, for the GCP setting up for static observation is GNSS RTK receiver. We use the CHG I50 base and rover, where based on the specs given, the positioning kinematic, horizontal and vertical is 8 mm and 15 mm with 1 ppm. Based on that, it's more than sufficient for area surveying because for area work, we are limited by the ground sampling distance. Typically, when we fly quite low of say 1 cm GSD, the max resolution, based on that 1 cm GSD resolution, the max accuracy we can get is probably 3 times of that GSD. Because you can't really pinpoint anything within 1 pixel itself of the image. So that system, we feel, is more than good enough for the test. Of course, comparing the M300, which has a 45 megapixel sensor on T1, and the Phantom 4 Pro, which is a 20 megapixel 1-inch sensor. So the area of interest that we took is over this whole compound, futurized magic area, as well as down there, there's some solar panels and the hotel down there. It's a total of about 20 acres in total. What we did was we set up a number of control points. The static observation point is at the center at CP11, right at this point. That's the static observation that we used, where we connected the CHG to Japan and RTK to go do it. And then we did the RTK points for the rest of it, where the entire survey work was done in UTM 47 zone. So the purpose of us doing this, of course, is to set up known ground points before we fly the drone to verify if the data collected from the drone is accurate or not. So for this one, what we did was for the 0.1, 5, 9, and 11, we used it as a verification point. The rest, we did use it some as GCP for the drone itself, and others we use it as backup points because some of them were already at the edge of the survey work. So we wanted to test as well what's the accuracy discrepancy for the points in the center of the image and at the edge of the map. So the ground control points that we put on the ground, for reference, for those who are not familiar with survey, looks something like that, where when we fly the drone up in the air, we can very clearly see the black and white checkered mark. And that's the center point of it, is where we would do the survey point. Okay, some flight parameters that we use, we try to keep as much things standard as possible. So the overlap is kept standard. Of course, the area, mission area is kept standard as well. What was variable is, of course, the altitude. That's the big one. Where for the first test, we wanted to fix the GSD ground sampling distance at 3 cm. We do have other tests as well that's way higher. So, and also the altitude at 100 meters. So that obviously would mean that the GSD would be different when you're flying at 100 meters. Where resident at 100 meters for the T1 is at 1.26 cm, which is extremely detailed. Can you imagine you're flying at 100 meters up, you're able to see down to a 1 cm pixel, which means you can see all your car number plate, people, face. I don't think you can recognize, but individual kind of steel bars and everything can be seen. So a bit of just playing a short video now to show how the entire data acquisition process works, especially for those that have not done data acquisition work before for survey. So typically what we have to do, the very first step before we even go to site is we need to define our area of interest, where are we mapping and where are we surveying. So this one is defined as this square. What will happen then is really a flight path will be generated where the drone will need to fly up and down to capture the images required. So at each of these points, it's taking a photo. And there's one thing to consider here is you would see that between each photo, there is an overlap. So there is a front overlap, which is where the drone is flying frontward and back, as well as a side overlap between each line. And these overlaps are very necessary because when we are doing the image processing and stitching later, we have to find common overlap points to stitch the map into a larger area. So all this, of course, will be stitched and it will be thrown into a workstation. There's a few software, DJI Pix4D, that is a really common one that will generate the maps for us. So I won't go into too much detail about the processing side of things because that will take probably a few days to do it. But on a high level, what we do is you will need to align the photos, make sure all the photos are aligned up. We built what we call a dance club model, which is in a way like points and everything to tie in the common points in between the images. Then we built the auto mosaic and the digital elevation model, where the auto mosaic is, if you can think of it as a high resolution Google map that you can really zoom in all the way and see very fine detail. And digital elevation map is like your, would say almost like a contour map where you can see your elevation, your slope profiles and everything from there. And for the processing for all these tests, all the processing parameters and all will be kept constant. For those that want a bit more detail about the parameters, we can speak after. So I don't want to bore everyone on it. So just a summary of the accuracy results that we managed to get. What we found was based on the 4 verification points we had, in terms of the XY horizontal axis, we could quite easily, over a few tests, get within 5 cm kind of accuracy. So not 3 cm as DJI kind of claimed in their marketing material, but we did confidently get 5 cm over multiple times. And of course, for the Z horizontal vertical axis, error is supposed to be about 2 times of the horizontal axis. We did get about 10, 12 cm error for the Matrice 300 up and down, depending on each test we did. And for the Fender 4 RTK, we got a slightly better vertical accuracy for this. So that's the kind of test result we have. We have a lot more comprehensive test results that we can share with anyone that is interested to look at a bit more. So that's what we managed to see, where we also looked at a lot of other tests around the world, and the kind of results that we got were very consistent with other countries as well. So that's the thing that we got, where the performance of the M300 and Fender 4 RTK, in terms of accuracy wise, it's pretty similar. We don't see a big difference between these 2 platforms, and it's kind of expected because if you break down the 2 platforms, the RTK module that is used between the Fender 4 RTK and Matrice 300 RTK is the same RTK module. So if it's the same RTK module, it should by right perform the same, as long as all the other camera parameters sync are all done properly. So that's what we found. Another thing that I'd like to highlight that would be a bit very different between these 2 cameras is of course the resolution of the sensor itself, where flying at 100 meter altitude, for M300 we are getting 1.26 GSD, whereas for Fender 4 RTK it's 2.74. It's about slightly over 2 times. And once you look at the pictures and you zoom in, you can very clearly see the difference between these 2 cameras. Both of it is flying at the same altitude. Everything is kept constant, but of course the resolution of the sensor is different. So very clearly you will see where the M300, you can see even down to the individual lines on the drainage cover, whereas on Fender 4 RTK you can't see, you just see a blurred kind of square object. And for of course survey work and construction work, sometimes this is very important. Sometimes you don't need to know. For example, plantation, we might not care exactly where the boundaries are to a centimeter level, but for construction, engineering, infrastructure, you have to get that kind of resolution. Okay. Another thing that I'd like to highlight as well is, assuming that we don't fly at the same height and we keep the GSD constant for both of the platform, for the 3 cm GSD, for Fender 4 RTK we'll be flying at about 110 meter, M300 will be at 240 meters. So based on this, you'll be able to see the difference, where this picture here is taken and the area covered by the Fender 4 RTK. But for Matrice 300, at the same GSD, you'll be able to cover much larger area, about 2.2 times, which makes sense because of the sensor size difference as well, the 45 megapixel versus the 20 megapixel. On top of that, right now the Fender 4, the P1, we are using a 35mm fixed lens. There is an option to change the lens to a smaller lens or larger field of vision, which means that we can cover much more than the Phantom 4 RTK in terms of per pictures taken. Because the Phantom 4 RTK has a non-changeable lens size of 35 mm as well right now, which is the same as the P1 in the default state. So just a bit of a summary in terms of the comparison between the Matrice 300 and the Phantom 4 RTK. Just a list of different specs. In terms of horizontal and vertical accuracy, you find it's roughly similar. Not much difference, considering that again it's the same RTK module installed. In terms of Rdk and Bpk compatibility, both has no issues. We are able to, number one, connect to, of course, DJI's own Rdk base station, but we are also able to connect to any third-party base station that are able to do encrypt casting. So that's possible. Of course, with Japan net Rdk base, when it's not down, for those that do surveying, you know what I mean by when it's not down, because it's always down like more than half of the time. And then Bpk compatibility as well, where on both of the drone, when it's flying, every mapping mission, there will be the right next file that is locked. So once you finish the flight, you have your log file on your base station and your drone itself, you can do your Bpk processing on any software. DJI have their own Bpk software, but most of the major survey brands, of course, they have their own Bpk software as well. In terms of the max operational flight, of course, we can't hit that max theoretical flight of 55 minutes and 30 minutes. In real condition, we are looking at about 40 minutes for the M300 and 25 minutes for the Phantom 4 RTK. This is including the takeoff and landing time. So the actual mission itself would probably be about 10-20% less than the time on the operational given. Distance-wise, similar. DJI claim about 15 km for M300 and 7 km for the Phantom 4 RTK. But in Malaysia, when we tested in semi-urban environment, we are getting about 10 km and 5 km distance from the drone. And this one, the 10 km, 5 km is tested in Cyberjaya, where I would call it a semi-urban kind of environment, not in the middle of the city, where there's too many interference happening, but out here. Of course, if you go to somewhere far away along the coast or in the jungle when there is not much radio interference, we can go further than that. In terms of the total area per flight that we covered, this one assuming at 5 cm GSD, because a lot of the survey work that we are doing, it's capped at, and that's the requirement that is below about 5 cm GSD. Per flight wise, for M300 we are covering 250 hectares. For Phantom 4 RTK it's about 60 hectares. And based on these numbers, if we extrapolate it for a one full day work, we are getting about 1,007 hectares with the M300 and 500 hectares with the Phantom 4 RTK. So of course the Phantom 4 RTK is a very standard multi-rotor drone, and the efficiency we see is very standard as well. But for the M300 RTK, because of the camera size as well as the flight time, we are getting almost very similar results to a sub 1 hour VTOL platform with a 42 megapixel camera. So when comparing it against other known platforms such as the EB or Wingcraft, we are getting very similar results. Plus on top of the fact that it's a multi-rotor and able to do a lot of other functions and features instead of just mapping. Wind resistance wise, of course, M300 is better, about 15 meters per second versus 10 meters per second. Waterproofing as well, where if there's slight rain, we would still fly. I think for survey and mapping, it's not that relevant since when it flies, the image quality typically is not good anyway. But for other applications, emergency, for example, if you are flying in Sabah, Sarawak, the rain comes very quickly. So that's where it becomes important, when you don't have time to even bring the drone back before it starts raining. Payload compatibility as well, able to compare, like Sazwan mentioned earlier, we are able to pair the M300 with a lot of different third-party payloads, whereas the Phantom RTK we can't, and applications as well. There's one big comparison that I didn't put on the slide, of course, it's the cost efficiency. So cost efficiency wise, I think later you can talk to our sales team. I wouldn't share it on the slide here because Phantom 4 RTK pricing is well known, but for M300, DJI does not allow us to put the pricing publicly. So we can't do that head-to-head comparison for that. So just to conclude, before we go out to the field to look at some of the features of the M300, how it flies, the flight planning, mapping modes, and so on. Accuracy-wise, which is of course super important for any survey work, both of it is similar. We are looking at about 5 cm horizontal, 10 cm vertical accuracy. For basic mapping applications, to be honest, for us as a service provider that we do survey work as well, for some simple mapping applications that require accuracy, we feel that Defender for RTK is sufficient. You don't need to spend too much or a lot more on the M300 with T1. But for complex applications where you want extremely high GSE, or you want to use the drone for other applications for inspection, surveillance, safety, then of course the M300 RTK with T1 is well superior compared to Defender for RTK. Alright, so that's a short summary from us about our case study and the results that we got. Of course, like I mentioned, we have a lot more data information that I haven't shared here because it will just bore everyone. So for those that really need more details, technical-wise, just feel free to reach out to me directly. So that's our contact detail. But now I think we open up to any Q&A on the product itself, the case study, and any other things before we head out to the field to test anytime. So anyone has any questions to clear up?
Right, thank you very much, Mr. Jinsey. It was a very thought-provoking and insightful presentation indeed. I'm sure all of us in this room are enlightened by the findings. Thank you for sharing. Mr. Jinsey, kindly remain on stage for the Q&A session. May I invite the Head of Sales, Mr. Justin, to join Mr. Jinsey onto the stage. Now we would like to open the floor for the Q&A session. We welcome any queries you may have. Please raise your hand if you have any questions. Our staff will hand the microphone to you.
So always in the morning Malaysia style, first question one wants to ask. Thank you.
Morning. Let me just ask the first question. By the way, I'm Jeff. Can we go back to the slides when coming to the accuracy?
Yep.
Okay. Do you manage to find out, basically, as we can see from the specs itself, the M300 RTK is basically more superior as compared to Phantom 4 RTK. So do you manage to find out the reason why the vertical accuracy is 2 times more off as compared to Phantom 4 RTK?
Yep, so the vertical accuracy, right, we found, to be honest, there is quite a bit of fluctuation between flights to flight. This is just one of the flights that we have. There are other flights that the Phantom 4 RTK is higher than the M300, and M300 is lower as well. So it's just, I would say we need to compare over a larger set of data, then it will even out and for both platforms. Because at the end of the day, like I mentioned, both platforms, the accuracy-wise, I mean the RTK module that we use, the receivers is the same. So we just wanted to compare if you give very similar results. Please.
Any questions from the floor? Please don't be shy.
Any questions? If not, we can go to the field to demo.
See the actual demo. Maybe after the demo, you guys have more questions, then you can feel free to check out our team. Yeah, I think everyone's more excited to see the demo.
Yeah, so let's go out and see the demo. The field is just outside, where we've already set up a large TV, where we will connect the remote control, the flight, which will show how do you do the flight planning, the live view from the camera itself, and of course if you want to test the other kind of platforms or the camera payloads and all, we can do that as well. So,
Alright, so we will now proceed to the entrance of this building where we will conduct a live demonstration of the product. Please follow our usher's direction to the venue. Thank you.
Dear honored guests, after the demo, the product.
Dear honored guests, after the demo, the product will still remain in this auditorium.
So if you guys are interested to check out more details about the products, please feel free to come back to the auditorium after the product demonstration. Thank you.
Saya nak boleh.
Hey, sure.